What is predictive maintenance? Allows the health of machinery to be continuously monitored. Components can be left in place until they start to show signs of deterioration. Reduces time spent on unnecessary maintenance, minimising downtime. That's a biggie there. Diminishes risk of critical part failure. Promotes uptime. And I think the most important part of this slide, supports engineering decision making. As we move forward, engineers are becoming on the front line. They are no longer just the guys that go out and maintain the plant. It's their responsibility to make decisions. Without the information, those decisions are diminished. Why use predictive maintenance? Without vibration monitoring, the only tools available are power consumption, temperature, oil analysis, and runtime duration failure. When I say runtime duration failure, there's many ways of carving that up. In the UK, we class that as firefighting. Basically, you run the machinery till it breaks, and then everybody runs around and tries to get the parts and shouts and screams at each other. Temperature on the failure curve is way above what a vibration sensor will be telling you. Power consumption and oil, again, in my opinion, and these are my opinions, they are further on the failure curve than vibration monitoring. If the sensors are installed, additional parameters such as acceleration and vibration can be logged and analysed, promoting uptime. With sensors, there's two sensors. Whoever manufactures them, there's two types. There is an AC, which is going to give you analysis where you're going to be looking at particular bearing failure, whether that be inner race, outer race, one of the ball springs as pitted, or you have vibration. And in my history of coming back and forth to Israel and working with the guys at Megatron, I understand that vibration is the big seller in Israel. It's a very understandable concept. We're putting sensors on gearboxes, we're putting sensors on pumps, we're putting sensors on motors. Those sensors are detecting package vibration. Then it's sending out in a 4 to 20 milliamp, which you can put into your PCs or your SCADAs. Without predictive maintenance, I'm not sure if things come out. Basically, these are three cutaways of bearing failures. You can see the races are scored. I would guess that's probably because of lack of lubrication. Machinery, if not properly maintained, will eventually break down. It's a fact. As engineers, we all have to live with that. Vibration sensors can tell us when parts are showing signs of wear and other damage. This gives accurate information to decide when maintenance should be carried out. Again, this is emphasising the same point. With the sensor, it's giving the information, it's going to show us trends, it's going to show us spikes. And as engineers, it's our job to interrogate the information coming back for us. But it is all about information. You know, not showing my age, but when I was an apprentice, my chief engineer basically used to take me by the hand and we'd put our hand on motors. He would then put a screwdriver and hold it up to his ear, and somehow magically he would tell me that the bearings are failing. I'm not sure he was true, but that's what we did. Chief engineers, certainly in the UK, were men held in high esteem. They are now, but there also need to be people that can produce charts, produce graphs, produce reasons, and this all falls back. This is a tree all the way coming back to vibration monitoring. Why fix sensors? Well, it's starting to be a theme here. If a bearing analysis sensor is fitted, trends can be stored and shown in real time what is happening. I mean, basically what I'm saying there is you know, if we put a sensor and we start analysing the information that's coming back, there's a term. It's an old term. It's an FFT algorithm. It was developed back in, you know, back in the 50s, 60s, and it's looking at trends in a sinusoidal wave. I don't want to go too much in that, but basically, with a package, you can start seeing real analysis on your bearings, and that's going to be done through an AC signal. Going on here, this unit is designed to detect acceleration at the natural frequency of failures. We'll go on further in the presentation. If a velocity sensor is fitted, overall movement vibration can be measured and transmitted via 4 to 20 milliamp current. Trends can be stored, plots can be created from the information being produced. And I think that's fairly self-explanatory here. You know, we all work in this world of 4 to 20 milliamp. Everything's 4 to 20 milliamp. Everything has a current. We can literally feed it in to anywhere. You do not need additional equipment. All of our plants have 4 to 20 milliamp. It needs a 24 volt DC supply. We have that available. You know, you are buying a sensor and you are fitting it on your equipment. You are not going to have to go out and get some sort of data acquisitioner. It's there. It gives you information. It empowers your engineers. Standard installation. Basically on your left, that would be a sensor, a stud, a bracket, and you could then bring it in the UK. What happens, and apologies for mentioning the UK, but you would bring it in a third party and he would then connect his piece of equipment. Basically what I'm saying here, we probably go with this setup on the right. That is, if I'm not mistaken, it's from a distillation plant next to Gaza, I believe. And that's just a typical online setup. And you've got it. And basically, you've got a pump, you've got the sensor, you've got the cabling, and that's just going to be feeding out information all the time. That information is going to be stored. And the way I've seen set up, the way we set it up, you know, of the 4 to 20 milliamp current, you have a first level alarm, you have a second level alarm. You will learn your plant. It will give you the information. Specific analysing techniques. I slightly apologise ahead of this. This just starts going into detail, and this is about bearing frequencies. Various signals processing techniques can be used to improve detection of different types of faults. For example, shock pulse separates the signal generated by repeated impacts from a background vibration. I think we understand that. Envelope G uses spectral analysis of signal envelope for early diagnosis of bearing faults. Envelope G is very important. We can use envelope G to maximise what's happening. RMS acceleration. RMS is a root mean square. Again, if we can mentally picture a sinusoidal curve coming up and down, we're squaring it off. We're making it into an analogue. Can be useful technique, for example, of out of balance situations. Spectral analysis is a versatile technique which differentiates between multiple fault conditions. Again, high frequency damage can be useful technique for detecting lack of lubrication or bearing damage. There's a theme coming here. Spectral analysis, useful techniques, especially for gearbox and complete gear trains. It reduces the effect of different mobility, reducing the effects of differing mobility of different measurements points. Again, you could be using one or two, you could be using all of them. These are techniques that we can employ, but without the sensor, none of this becomes available. Generic AC sensors, Again, an AC sensor is going to give you a voltage output. And AC sensors are fitted to some form of rotating machinery, such as a felt roll in a paper machine, a gearbox in a wind turbine. Our business dictates that wind turbine has become the default setting for the globe. Every country does wind turbines, whether they're producing energy or not. You know, in the UK, for some unknown reason, we decide to put them in the sea. I don't know why, but we put them in the sea. The amount of energy, the amount of money it costs, we're never going to recoup anything, but we do tick the green box. And they have our sensors, bless them. Every country has to go down this road. It's where it is. Signal output will be interrogated by a data logger connected to the sensor. This will ascertain the bearing condition, showing any deterioration which can be monitored and the parts replaced when required. There's the tag, parts replaced when required. You know, you're in charge, you're making the decisions. I think this is really maybe where we start hitting home here. Generic DC sensor application. DC sensors monitor for imbalance, bearing wear, looseness, blockage. You know, we've had. I've been here since Monday, and we've spoke to a number of people, and the ongoing theme is trying to analyse pumps, what they're doing. Are they cavitating? Are they blocking? Are the bearings failing? Is the belts coming off? Are the impellers coming loose? I don't know. But without some form of monitoring, nobody else knows. Any change of condition will be detected and produce an increased signal, which in turn will trigger a decision. Again, there's the tag, produce a decision. It's making someone do something. It's a flag. It's empowering. You know, we may choose not to do anything, but that's a decision. But someone has to make that decision. The demand for 4 to 20 milliamp output sensors has risen with the onset of control rooms, computer software packages, i.e. SCADA. I make an assumption that SCADA's here in Israel because it's pretty much everywhere else. And again, two very typical installations on screen. A little bit about the sensors. Sensors, we manufacture both piezoelectric and piezo-resistive. To put a bit more expand about that, piezoelectric are a standard sensor. You're going to get them. These are the ones that our friends at Megatron mainly sell. They're a general sensor. You're going to put them everywhere. They start at around about 2 hertz and they go up to 1,000 hertz. So they're gonna cope with everything you've got. Piezo resistive, slightly different. They'll go down to DC, so from 0 to 500 hertz. Very slow moving equipment. You'll be able to get some feedback from them. It's horses for courses. That may not work here. It's whatever sensor for whatever application. Wide choice of standard models plus a bespoke custom design. That's a little bit salesy. You can see across the bottom, you have an application, we have a sensor. As I say, we've been doing this for 35 years. We've pretty much covered most applications. If we haven't, I really want to get involved because I want to see new applications.